Hey guys, welcome to Programming Knowledge. In this video, we'll be looking at templates in C++. Now, what are templates? Well, templates are a way to define generic functions or you could say classes in C++, right? So, we'll just take an example to understand that better. So, let's say I have a function called add, which is really simple. It's just going to take in two numbers and return me the sum, right? So, this is a very simple function, and you know the drill. Just call this one, two, and look at the output, and no surprise that this is just going to return me 3, right? So here we have the output. Now what I could do is, let's say I wanted to create a function which can add floats. So instead of 1 and 2, I'd say 1.2 and 2.3. Now, as you know, this is just going to go inside this function because float can be converted to an integer. And once you're doing that, you are just losing this data. So that's not expected, right? So even if you run this, you'll be getting 3 as your output. There's no errors, but you did not want 3 to be the output. You wanted 3.5, right? Because you wanted to consider both the decimal places too. Now, the fix you would say is, well, just change this, change integer to float, because if we convert an integer to float, there's no problem in that, because anyhow the decimal is just going to be 0. And if you want to process floats, you can directly given floats over here and it's just going to process it the same way. So if I just do that, that fixes the issue. But now I'd say that I want a function to add two strings, right? Well, we don't need a function for that. You could just do plus over here. But anyway, let's for an example say we want to add two strings, or two objects of our custom class, right? So let's say I defined a custom class. Well, let's say complex number. Well, complex number is too mathematical. Let's say, well, let's just say ABC, right? So our class is ABC, and you have defined a operator called plus inside that. We'll see how to do those things later. That's kind of advanced. This is called operator overloading, where you say that plus should work in different ways for different data types. So if it's a float, integer, or number, basically plus should basically mean the arithmetic addition. And if it's a string, as it's defined in the string class, you just concatenate. So basically hello plus world becomes hello world, right? So those things we'll see later, but let's say for now that I want to do that. Now, is there a way could that I can use this function to add a string to? No, right? I cannot do that. But I could define another function called string. So string add, say string x, string y, and I could just return x plus y. This is completely valid. And if I just call the that function using two strings, so hello and world, right? I forgot the endl. Run this, I'll be getting hello world over here. So this completely works and it's fine. But what happens if I have more and more types of data which I have defined? So basically, data of custom classes or instances of custom classes. This is not at all practical, right? I cannot write so many functions which do the same thing, which do the exact same thing. So in this case, it's just adding those two numbers, right? So is there a way I could automate this? Well, there is a way, and that is when the use of templates come into play. So what we are going to do here is we are going to define this function not as a function but as a blueprint, so that the compiler knows that, yeah, if this is the input, I need to create a function in this way so that this function gets executed. So that's what templates do. So it's very simple to create a templated function over here. So what you do is you just say template, and inside a pair of angular braces you just specify the type. So it's called type name or class. It really doesn't matter what you call it this stage. It's a very small difference between class and type name, but we'll just get into that. But for now you could just call it anything you want. So let's just go with class. And what you just name your custom class anything you want. So this is just basically, it's like a variable for the compiler, so that anything I put in there, the data type comes into this place, right? So you could just call it anything. Generally people call it t, right? T for template or anything. So gt, whatever we want, you can just call it, right? We'll just stick with T. And here what we'll do here is we'll just below that template definition, we'll just use our custom created class. So T add, well, it's not float T, it's TX and ty. So what happened here, what I'm doing here is that now I don't need this function, right? What I'm doing here is that I just created a template of this function called add, and it's just going to take any data type which uses this function inside this. It's just going to create this function inside the memory and it's going to call that function. It's as simple as that. So here if I do 1.2 2.3, what it's going to do, 1.2 and 2.3 are floats, so it will create a class called float. So it's basically it's going to look inside the memory. It does not find anything because this class is just a pseudo class, it's just a template, right? It's a blueprint, and this function does not really exist. But here I have called that function, so it will just look at the template, right? So it has this blueprint, it knows what to do. The class is T, so basically class is float. So what it's going to do here is just define that function using float. So float x, float y, and return x plus y. So this part it's going to do automatically, and we'll be getting this function. So here if I call strings, it's just going to create strings. If I call integers, it's going to create integers. If I call abc, it's going to create this function for abc, right? And other another thing is that this operator should be uh, defined for that class. So for now we'll just assume that this operator has been defined for whatever class we are going to use. But in case it's not defined, it's just going to throw in error, right? So this is as simple as that, to define a template or a generic function. So this is an example of a generic function. You could just use this function and create whatever you want. So here I could just use this for floats, I could also use this for integers, or I could just use it for strings as I've used here. So let's say integer first, 1 2, right? And then the strings, run this. Okay, I have an error. What does it say? Okay, it says const char star cannot be added. That's because here we are passing in strings, and we'll get to that in a moment, right? That's a simple fix, but we'll see what happened over here. But now, for now, let's just see the output and then analyze it. So here we have the floating point output and the integer output, and that's what we expected. Now coming back to the error, what happened was when you pass this function, it's as I told you, it's a string is nothing but a array of characters. So when you define a literal like this is called a string literal. And if I just define something like this, it's just going to be an array of characters inside the memory. And as you know, there is no plus operation between two arrays. If you want, you could create a plus operation between two arrays using a custom class, but we're not going to get into the details right now. But basically, if you could create an array class which would support this plus operator, this two would have been concatenated and we would have got the output as we wanted. But here what is happening here is that we are allowing the compiler to determine for itself. So here we are just passing that input, we're not providing any additional information as to how these inputs should be passed or anything like that. We're just calling that input, we're just calling that function, and the compiler is left to determine what we're doing with this, right? So the problem arises over here when we are using something which the compiler does not understand. So for a compiler, this is not a string class objects, right? A string class is something which is defined outside the compiler. Integer is defined inside the compiler, character is defined inside the compiler, but there is no string which is being defined inside the compiler. So for this is nothing but a character array, right? So it's just trying to add two character arrays, and that's why that was not successful and it threw an error. So the way you solve this is you explicitly specify how to pass this output inputs, right? So how to pass these parameters. So that's what we did when we were using vectors. So if you remember, the way we defined a vector was we did something like that, right? So this is the thing which goes inside this thing. So that's how a vector class has been defined. So whatever you pass in here, it's going to go inside this thing, right? So that's the same thing we need to do here. So let's say I want to parse these things or process these two parameters as float. I'll just say float here, right? I want to process these two things as integers, so I'll just say integer over here. Process these two things as strings, just say string over here. And now if I run this, I will not be getting any error, and I will be getting the output what I expected, right? So that's how simple it is to work with generic functions. Well, you could have multiple parameters over here, so class t or class n, whatever you want, and the you could just specify what input and what output you want. So that is also possible, right? So that's about templates in functions. You could also do it for classes. So let's just quickly take an example. So um, what would be a best example? Let's say we want to create a class called let's say storage, so class storage, and it's just going to store um, some data, right? So it's just, let's say, private, let's say stack, or what do we call this? We'll just call it store, right? It's just going to store this. So let's say an integer array of store, and it's just going to store some number of data. So in C++, now you know that this won't work, because you're just creating an empty array. You need to specify size to the array. But now every storage will have a different size, right? I cannot create different storages with different sizes. Well, I need to do that outside this class. But what if there are some important functions? Right now there's nothing. It's just holding this store variable, right? But what if I want to create a class which has kind of functions? Like, you have the vector class. Vector class is a very good example of this, because you have very good functions inside the vector class. You have functions for finding, sorting, and all those things, which we need to define it outside if we wanted to use it for different sizes. But inside the vector class, you're just using it without defining anything, right? You're just using the inbuilt things, right? So the way you do that is really simple. Just use another type. So type, sorry, template, and it's going to be integer, because I'm not specifying a class here. So if you remember, I used to do something like class t, but here we know the type, right? So you're just going to pass in some size. So I'm just going to say int, right? So int size, well, size is, let's just say s, right? So int s, and I'm just going to create the class with that size, right? That's as simple as that. Now you could create a storage of how much ever space you want, right? So I could just say storage, and let's say 5, which is going to hold just 5 elements, and then s1. Or I could just say storage 10 h2, right? And this will work perfectly fine. If I just run this, I have a successful compilation, and it has only created those two classes with only that much size, right? And if I wanted to, I could even specify the type of data it's going to store. So let's say, even well, that is going to be generic, right? We don't know what type of data we are going to store. So here comes the class D, or whatever you want. So class, let's say, some class, you can just name it whatever you want, doesn't really matter, right? So you could just say that, and it's just going to be some class of the store s. And here what I would do, I want to store 5 items of integer, and here I would store 10 items of class string. Run this, I'll be getting a successful compilation. And that's how useful templates are, right? So with just one additional line, you could actually create a generic function which could be used anywhere and for any class. Well, for any class, it's a very vague statement, because whatever functions we are defining, that should be applicable to that class. So in case you saw over here, hello and world, if they are treated as character arrays as a compiler treats it, that's not going to work. But if I treat it as a string object, well, string is a class, it has this plus operation defined between two strings, so it works, right? So that's how it is. You need to specify this template keyword along with whatever generic types you want. And also you could also type specific items over here. So in my case, the size is an integer always, right? So you cannot have a 3.5 blocks of data or something like that. It's just going to be 3 or 4, so I know that it's going to be an integer, right? So just specify integer over here. And class can be any class. You could just create a store for any kind of class over here. So that's how we use templates. And yeah, the difference between the class and type name, I forgot about that. So class is basically an independent thing, so independent, right? And type name is used when it depends on something, right? So this is not a very big it's not a very big thing to interchange these two things. It's not going to make any difference when we're just using something like this. So here class and type name mean the same thing semantically, but where it gets useful is that when you have chained template. So I have a template inside template, so template inside template, something like this, right? So now what happens here is that this template will depend on this particular template, because that's how we have defined the template over here. This template is actually something which uses this template, so it's dependent. So in that case you use type name, but if it's not dependent, it's independent, then you use class, right? Well, this is a very in-depth problem which you may not probably encounter, but in case you encounter, this is the error, and this is how you fix it. If it's dependent, you just use type name. If it's independent, you just go with class. And if you're just using simple templates like what we used over here, right, which is completely independent and it's just a one level template, it's just the top level template, right? It's not dependent or independent, whatever it is. It's just it's just unique, right? It's something which we have defined on a very top level, and it does not depend on some other classes or some other template or whatever it is. So in that case, well, you could just go with type name or class. You could use that interchangeably, whatever you feel comfortable with. It's not going to make any difference, right? So that's about templates in C++, and that's how you create your own generic classes. So now you know how to create a class for vector, right? It's basically the same thing what we did here. It's a very simplified version of a vector, or you could just call it an array, because the STL contains an array. Well, the STL is called STL because it uses these things. That's the thing, right? So STL, the full form of STL is standard template library, and it uses templates. So that's why it's called STL, right? So whatever things you find inside the STL, it's all templates. So, and this is how you build up a generic class. Well, I did not put anything over here. It's well, you just put that, right? You get that, right? So whatever you do here, that's basically templates. And in the next video we'll just go over some of the very useful STL. Well, everything is useful inside the STL, but some are very high standard, but some of the things you just use normally. So there's this algorithm class which you could use, the vector, the list, and all these things. We'll go through some of them in the next video. Till then, happy coding.